Dear students, welcome to Yamuna Physics. Today we are here to discuss the topic Earth's magnetism as well as magnetic elements of Earth. This is a topic of lesson 5, magnetism and matter. Okay, so that here we are going to consider Earth as a magnet. Earth has a magnetic field around it. That magnetic field around the Earth is arising or considered to be arising from an effect known as Dynamo Effect. Dynamo Effect is dynamic means moving. So something well inside the Earth is found to move. That something is in a molten form of iron, nickel, etc. So inner core is somewhat solid, but just the outer core of the Earth has this kind of fluids in a molten state which are in a state of motion. As Earth is rotating, along with that it is rotating, as such there is some sort of current is being produced. That current results in magnetic field. So here we are considering Earth as a bar magnet. A huge bar magnet is supposed to be embedded well inside the Earth, and that reason of that magnetism is this dynamo effect. So let us go to the detail. Number 1, regarding Earth we need few points to memorize. Number 1, you know there is a geographic north and there is a geographic south. If you have a globe, you know it is rotating about its own axis. Earth is rotating about its own axis. There you have a north pole and a south pole. So axis through that is known as axis of rotation of the Earth. And on the globe you have seen longitudes. Too many longitudes are there over there on the Earth, and that longitudes make circles over the surface of the Earth. So some circles are there which is passing through north to the south, again north to the south, like that. And if you complete that longitude in a circle manner, you will have the diameter as geographic north and geographic south. That is what you know already with a globe or the Earth. Now here we are aiming new two terms known as magnetic north and magnetic south. It means just a freely suspended compass needle, it will look to, the word is north seeking pole, means the north end of the compass needle look towards geographic north. Similarly, the south end of the compass needle looks towards the geographic south. But that two points never coincide. This north magnetic point, or where the compass needle is looking to, is somewhere a point very nearly 79 degree latitudes, close to northern Canada, and here it is somewhere south, it is nearly very close to the Antarctica. So these 2 points, magnetic north and magnetic south, are, I repeat, those are the points where a freely suspended magnetic needle comes to rest. Okay? Now joining these 2 lines, you will get a line which is passing through magnetic north and magnetic south. Now if you plot the magnetic lines of the Earth, so these 2 are equators, you can see 2 in different colors. Number 1 magenta, that shows geographic equator, what you know. Now you have new term, magnetic north, magnetic south, and that equator is known as magnetic equator. Now if you plot lines of the Earth, if considering Earth as a magnet, if you plot lines, it will be somewhat like this. You look at this, lines are coming from here reaching here. But when you think about the magnetic field lines of a north-south bar magnet, it seems controversy. It seems some kind of difficulty in understanding the concept. So you can imagine, like inside you have a, I told you, due to dynamo effect, there is some magnetism well inside the Earth. That particular magnet well inside the Earth again has 2 poles. So that bar magnet which is well inside, you don't have a bar magnet inside the earth, but you can assume to be a magnet well inside the earth, whose north pole is situated in the southern hemisphere and the south pole is situated at the northern hemisphere. Then you try to plot the lines, so it is okay. So if that is the case, all the lines are coming out from the north and they are reaching at the south. So now everything is clear. I repeat, you have a geographic north, geographic south, and you can have a vertical plane which is passing through these two, geographic north and south, and that will be like a longitude circle cut in a plane. So you will have two spheres, hemispheres, not spheres, hemispheres, with our geographic axis or the axis of rotation of earth as diameter. Similarly, if you have another cut in this manner with magnetic north and magnetic south, and if a plane is passing through them, it is known as magnetic meridian. So two new terms, one is geographic meridian, the other one is magnetic meridian. And the angle between that two planes, not lines, I mentioned it is plane. Plane passing through NG and NS, that is geographic meridian. Plane passing through NM and SM, that is magnetic meridian. And it will be somewhat like this, cross like this. So that angles, opposite angles are the same. So this angle will be same as the other angle. And roughly the value is 11.3, but not always. This varies from point to point. If you go over the surface of the earth, the value goes to be different. At equator, it is nearly 0. When you go to the poles, it goes on increasing. So that's all with the term declination. So what is declination? Declination is a term defining angle between GM and MM. Hope GM and MM is clear. Now you have two more terms. The one is known as dip or declination and the other one is known as BH. Dip means something is dipping down or up. So dip in the sense coming down or up from a particular point. So let me see what is dip. Dip in the sense we have compass needle. Usual compass needle is pivoted somewhere like on a vertical pivot and it is rotating in a horizontal plane like this. But dip needle is the reverse thing. Dip needle means it is pivoted horizontally and the dip needle is moving like this in the vertical plane. This is a magnetic meridian plane. So dip needle will be going like this and this. If the dip needle is placed at equator, it will just remain like this. But when you take it from equator to the north or the south hemisphere, you can see that this will be dipping, hence the term dip. The dip needle will be coming down or moving up as we go from northern and southern hemisphere. So that is dip from the horizontal level. So if this is the original position of the dip needle, it is pivoted like this. I told you this is a suspension, like a seesaw. Yes, very simple, like a seesaw. So this is seesaw. So suppose this is seesaw. At some time it will be coming like this, sometime it will be coming this way. So this is the horizontal position. So that is the dip needle. If you have such a kind of dip needle and if you place somewhere on the surface of the earth, that is known as dip. Now let me explain what is declination and dip. And we need another two more terms, BE and BH. So we draw all this figure to show what is BE. BE means Earth's magnetic field. I told you BE is Earth's magnetic field. Earth is considered to be a magnet and it has magnetic lines of force similar to that of a bar magnet, well inside the earth. So as such it has a direction. And what is the direction of BE? For that we draw this diagram. And what is this? We have two lines or planes. Here we have drawn the lines. We have two longitude circles. We have taken two longitude circles. Now what is longitude? Lines going from north to south over the globe, you have seen. That kind of two circles I have taken. One for magnetic and this is for magnetic circle. and this is geographic circle. Means a line passing through a circle which covers NG and SG in longitudinal circle. Similarly, another circle which is going from magnetic north and magnetic south. So we have two kinds of circles. So as they are passing, they intersect at some point. Let that point be P, and P is on the surface of the earth. So take a point P on the surface of the earth. And at the point P, you have two circles I told you. One longitudinal circle for geographic meridian, another longitudinal circle for magnetic meridian. At the point P, you are going to have two tangents. One for circle magenta showing geographic meridian, the other one magnetic meridian. So this tangent is similar to that of NG-SM direction. That means this points north-south direction, geographic north-south. And this blue tangent shows parallel to NM and SM, showing that is parallel to magnetic south direction. So this shows magnetic north and south direction, this shows geographic north and south direction. And what is the angle between them? We have already written as D. So this figure is very clear for you, D. But there is a point which is not clear, a yellow line is here. That is not clear. So with these two are lying in one plane. You can see AB and the point P is a part of a rectangle which is in the same plane, not line, plane. With that particular rectangle, I construct a parallelepiped. And that parallelepiped has a diagonal starting from the point P to the opposite point. That line is PC. And this PC shows net magnetic field BE. So dip is defined as angle between angle I is defined as angle between BE and BH. So you are getting BE from the figure. Now you need to cut this into two parts. BE is resolved into BH and BV. BH horizontally, BV vertically. So in our lessons we are writing only, if the question comes what is the magnetic elements of earth, you will just write this, you will then write this much, that's enough. But when you go to NCERT text, maybe you will have a doubt, how comes a parallelepiped? What are the directions there? So this I just want to explain what are the values given in the parallelepiped. Number one, once again repeat, this is the tangent to what? Longitude circle of geographic north and south. This is the tangent to magnetic circle or magnetic meridian whose tangent is PB. Now the angle between them shows dip. Now with this one you are constructing a parallelepiped so that you can have a diagonal from the point P to the opposite side. That PC denotes net magnetic field, means total magnetic field at any point P. Because we know for each point on the magnetic field line, if you have a tangent, that tangent gives the direction of the electric field. Sorry, magnetic field, that tangent gives the direction of the magnetic field. That's an important property of magnetic field lines. So you will have that. So how did you get that value? This is how you get it. And finally, this BE, which is the diagonal of the parallelepiped, can be cut into two parts. One is horizontal, the other one is vertical. Resolution of a vector into 2. BH horizontally, BV vertically. So that angle which makes between BH and BE is known as I, that is dip or inclination. Hope it is clear. Three terms: dip, declination and BH are the three magnetic elements of the earth. Clear? Thank you for listening. Thank you.